Okay, on this 3.4, you already have the formulas down. So if we were asking, what is the sine of 75 degrees? Okay, what two numbers would add up to make 75 degrees? It'd be 45 and 30. So the formula for the sine is the sine of the first, the cosine of the second, and then you use the same sign, so this time it would be a plus, the cosine of the first, the sine of the second. Okay? So sine, cosine, cosine, sine, and the sine is the same. Okay? With a cosine, it's cosine, cosine, sine, sine, and the sine is the opposite. Okay? But you have a note card to have it down, so it shouldn't be a problem. Sine of 45 degrees is square root of 2 over 2. Cosine of 30 degrees is square root of 3 over 2. Cosine of 45 degrees is square root of 2 over 2. Sine of 30 degrees is 1/2. So it's square root of 6 over 4 plus square root of 2 over 4, which is square root of 6 plus square root of 2 all over 4. Any problems with any of that? Okay? That's just like last time. Now it's the tangents that are a little more problematic. The tangent of 15 degrees. That equals the tangent of what and what? What would you go with? 45 minus 30. And I'll show you how that might not be the greatest idea in the world. But this is why we do this, so we figure out and learn from it. Okay, the tangent of 45 minus 30 is a tangent of 45 minus the tangent of 30 all over, is it 1 then? 1 plus the tangent of 45, tangent of 30. Now, if we list our tangents out, if we list our tangents out, what's the tangent of 30 degrees? Is a sine of 30 over the cosine of 30, right? It's 1/2 over square root of 3 over 2. So if we multiply them both by 2, it is 1 over square root of 3, and multiply top and bottom by square root of 3. So you get square root of 3 over 3 is a tangent of 30. What's the tangent of 45? 1. What's the tangent of 60? Square root of 3 over 2 over 1/2, right? So if we multiply both the top and bottom by 2, it's square root of 3 over 1, or just square root of 3. So if we do this problem, 45 minus 30, it's 1 minus square root of 3 over 3 over 1 plus 1 times square root of 3 over 3. Is everybody picking up what I'm putting down? Okay? Now, we've got some complex fractions going on, right? So how do I get rid of the complex fractions? Multiply by the denominator. So if you distribute the 3 through, you get 3 minus square root of 3. On the bottom, if you distribute the 3 through, you get 3 plus square root of 3. Now you go, well, that's the answer. And I go, no. Why not? Can't have a radical in the denominator. How do we get rid of that out of the denominator, especially if there's a plus sign in the denominator? Multiply by the conjugate of the denominator. What's the conjugate of the denominator? 3 minus the square root of 3. So whatever you do to the bottom, you have to do to the top. So if we FOIL the top, we get 9. Outers is minus 3 square root of 3. Inners is minus 3 square root of 3. Last times last is plus 3. In the denominator, they're conjugates. So 9, outers and inners cancel, minus 3. So you get 12 minus 6 square root of 3 over 6, which is 2 minus square root of 3. Because if they both divide by 6, there we go. Tangents, a little more problematic. Now, I'm a really good square drawer, aren't I? Yeah. Watch me draw a parallelogram, a perfect parallelogram. Oh, look at that perfect parallelogram. Yeah, I've got ink to shape turned on. So, oh yeah, let's turn back on ink to shape. Boom. Circle, perfect. Trapezoid, perfect. Isn't that so cool? I was doing that. I just discovered that this morning, so I was doing it for some geometry stuff. Yeah, if they had touchscreens, but they don't. Okay, so you have a complex fraction there. The tangent of 15 is also the tangent of 60 minus 45. How does that change a problem? Not very much, but it's the tangent of 60 minus the tangent of 45 over 1 plus the tangent of 60, tangent of 45. Well, what's the tangent of 60? Square root of 3 minus 1 over 1 plus the square root of 3. Okay? So, if we do that, and then we FOIL, we'd FOIL it by what? 1 minus square root of 3. On the top, we get first times first is square root of 3. Outers is minus 3. Inners is minus 1. Last times last is plus square root of 3. Over on the denominator, we get 1 minus outers, inners cancel, 3. So we get negative 4 plus 2 square root of 3 all over negative 2. If we divide everything by a negative 2, we get a positive 2 minus a square root of 3. Okay? So we get the same answer. It's just a different route that we took. Okay? Let's do one with radians. How about we do the tangent of negative 5 pi over 12. How do I get to a negative 5 pi over 12? How about 3 minus 3 pi over 12 minus 8 pi over 12? Okay? Because if you took 2 times 7, we don't have a 7 over 12. If you took 1 times 1 minus 6, we don't have a 1 pi over 12. So, yeah. So it's the tangent of pi over 4 minus 2 pi over 3, correct? Which is the tangent of pi over 4 minus the tangent of 2 pi over 3 over 1 plus the tangent of pi over 4 tangent of 2 pi over 3. What's the tangent of pi over 4? 1. 2 pi over 3. That's up here. Okay? Up there we have 1 half and then square root of 3, negative 1 half and square root of 3 over 2. So it's square root of 3 over 2 over negative 1 half, which is just negative square root of 3, correct? Over 1 plus 1 times square root of 3, negative square root of 3. Plus or minus a negative in my numerator is plus a positive. So I really have 1 plus the square root of 3 over 1 minus the square root of 3. What do I FOIL this by? 1 plus square root of 3 on the top and bottom, because it has to be the conjugate of the denominator. So 1 times 1 is 1. Outers is square root of 3. Inners is square root of 3, so it's 2 square root of 3. Last times last is 3 over 1 minus 3. So my numerator, I get 4 plus 2 square root of 3. My denominator is negative 2. So if we divide them both by negative 2, I get negative 2 minus square root of 3. One more, or are we good? We're good? Okay. So, lesson plan book. 9 through 16 all, page 165, only assignment for today. 16 all, page 165, I think it is. 185, sorry. Page 185. 9 through 16 all, page 185.